Okay, so what's up? So this one's a different situation now. So here we have, notice what it says up here. This is kind of important right there. That means that L is parallel to M. L and M, which means this line and this line, L and M, are parallel lines. They're exactly headed in the same direction, like, railroad tracks that are parallel, or two, parallel streets that both head in the same direction. So those lines, that's how they write it geometrically. So they put the straight lines between them. That means L, it's shorthand notation for L and M are parallel. Okay, and then they want us to find all the other angles. Well, I'm going to give you 2 or 3 key facts that'll help with this. The first fact is diagonal angles are equal. Diagonal angles are equal, and they're called vertical. I don't know why they're called vertical. I don't think it's a very good name. But what we mean is, if you have like an intersection, let me show you. Like look up here at B, angle B, and the 62 degrees or whatever you have there, those have to be equal. In other words, B has to also be 62 degrees. That's what we're able to figure out right away. Why? Because they are diagonally across from each other. It's called vertical, but I think they should have called it diagonal, but it wasn't up to me. They call those vertical angles, angles that are diagonally across from each other, and they've got to be the exact same thing. And it looks like it too, doesn't it? Right? Doesn't it look like angle B is less than 90, for example? There's 90 right there. B is less than that. So B is less than 90. And doesn't it look like A is less than 90? They look like the same opening. They are. They've got to be, don't they? So diagonal angles have to be equal to each other. So that's helpful. So right away we can find out that angle B is also 62 degrees. So now we need another fact. And then the second important fact is that Z angles are equal, and they're called alternate interior. So that's the fancy geometry word. Alternate interior angles are equal when you have parallel lines. So when you have parallel lines, the Z angles, I call them Z angles, the alternate interior angles will be equal. So what do I mean? Well, just think about if you make a Z, just like the big Zorro Z there. So this angle and this angle, right? A Z naturally makes 2 angles. Those 2 angles have to be equal if the top and the bottom of that Z are parallel lines. Those angles will guaranteed be equal. So let's see that on the diagrams. I'm going to make the Z right here. So there's the Z right there. And notice the 2 Z angles. It's this one and that one. So therefore, D has got to be 62 also. The 62 is spreading around. Right? Why? Because those are Z angles, technically called alternate interior angles. Alternate interior angles. I should add that word. So now let me show you why they call those alternate interior. Well, first off, they call the official terminology, this line right here that cuts across the 2 parallel lines is called, this one is called the transversal. So they will use this terminology probably in whatever textbook you teach out of. When you teach the math lessons that you will teach, they'll use these words. So I want you to know these words. because they'll show up for you. Transversal. So that's the line that cuts across. Trans just means across, like to transport something means to carry it across. Trans is across. So the transversal is the line that cuts across the two parallel lines. So those two parallel lines, right? Remember L and M are parallel? L and M, those are parallel lines. So if you go from this intersection down to this intersection, then notice that this D and B are inside the parallel line. So let me highlight that. So this parallel line and this parallel line, notice D and B are both interior. See why they're called interior? They're inside as opposed to outside. They're not out here and out here, right? Like A, let me draw it again. F and A, those would be exterior, or G or the 62. Those are exterior angles. Those are outside of the parallel lines. We're talking about B and D, which are interior angles. That's why they're called. And they're also called alternate. Why are they called alternate interior? They're interior, but why are they alternate? Because they're on opposite sides of the transversal. See how this one is on the left of the transversal, that one's on the right. Like two people living on opposite sides of the tracks in town or something, right? Those are called alternate interior angles because they're on opposite sides and they're both interior. Alternate interior angles, I call them Z angles because it's just easy to see it, are always going to be equal. So these two have to be the same. They're 62. Now you know what we can do, right? We can find F because it's diagonal. It's got to be 62 also because it's diagonal from D. We already know diagonal angles called vertical are equal also. So we got half of them. Now, what am I going to do to find, like, let's go down and find A. How am I going to find angle A down there? Anybody know?
Would you subtract 36 from 180?
Yeah, or whatever angle you have. Yeah, exactly. Subtract from 180, huh? Exactly. Because these two have to make a straight line, don't they? Remember? Two angles that together make a straight line, that's half a circle. Halfway around, which is 180. Yeah, exactly. So then we just use that fact that we've already learned. 180 minus 62 is mine. I get, what is it, 118? So for mine anyway, it's got to be 118. And then this one's diagonal, so it's got to be 118. Same thing up here. These are 118 because they have to make a straight line with the 62 also right there. So yeah, there we go. We got them all. So all those angles are either 118 or 62 for mine, and then whatever for yours. So what are the key facts we use? Diagonal angles called vertical are always equal. And Z angles, what I call them, but they're really alternate interior angles. When the lines are parallel, they are equal. They're equal. Z angles are equal. Alternate interior angles are equal when the two lines are parallel. They gotta tell you the two lines are parallel for that to be the case.